Alright, so today I want to start very slow and step by step. So you're starting a new project, you click on project, it comes up with this dialog box, project dialog box. Go to new single user. We are not using vote, so it's going to be new single user. You name your project, my first project. Yeah, okay. Then workspace, you set your workspace. You come here, you create a folder. Right here I have something called demo on this place, so I save it in the demo folder. So it's going to save all my project in that workspace. Then I click on next, finish, and I have what I want right there. Then you done. Now this project, any new thing you're creating is going to be inside that project. So when you click on new, that's new part. You're going to see this with this. So new, so you select the template metric, that's what we use in Nigeria. Select either the part you're starting with, create on create. Alright, so you create. Alright, so when you create, it's gonna come up with a part. So I'm doing sheet metal modeling, so that's why I choose the sheet metal part type, not solid. So this is gonna launch a new part for me, and well, you don't need this one, it won't be on your own, so let me just close this. So when I have this right here, okay, so one of the things we set up first is what sheet metal thickness do we use. We set it from the rule, or you change thickness directly from here. Sometimes most people like set from the rule because this is like overriding what the rule thickness is. So let's say 2 mm. Save, it's better, and it's already override. Show you what is there right there. So now that's it. Then first thing, save your part. You do save, and you see it's taking you to that folder called demo. Yeah, that's the first one that opens. So if you click on workspace, it's always going to be the demo folder. So when you are in the workspace, what we do is you create a new folder for parts. So in this folder you have all your parts. You create another one for assembly. That's what we do, such that it's easy to manage our files. So then we also create a new folder for IDW. First thing we do when we start a project. Then so all the part goes into this place. We name it, we give it a part number. We can say it's a main body panel. It's like a long jargon, so you could say PT engineer ENC class part of an enclosure 001, depending on how far you're going. So alright, then you start with your design. So I want to design something basic, so let's start with a random enclosure, maybe a freestanding enclosure 500 by 500. So you start with just with your main body. So this is gonna be a main body. I've actually not thought of it, but I think let's just do something. So main body. So I want the base to start from here. So this is gonna be the main body. I'm gonna have a flange around the whole thing. Then I'm gonna put a door in front, so it's just gonna be a really small enclosure. So for this one we want the width, the type, you're creating your parameter width equals to, so let's do 450 mm. Then your height, as your height, let's do 600. So you have to type height equals to just the way I'm typing it. So you creating parameters right from the beginning. It's easier to manage like that. So great. So with this I have my main body, and I create a face from that. So once you create a face, it's automatically select any close contour, and you set it to OK. There you go. Over here you use flange. So I want a depth of let's say a depth of 250 or 300. So this is going to be 300. So so this one, what we want to do is there are ways to do this. Anything that is coming from that, so you see I want to select other edges, so I have to come here to add to the edge, click inside that box, then click on the edge. So I want the depth of 300. Now sometimes when we do this, we always consider the capability of the tool. That's the best way to bend these things. If they are, if we want to cut some clashes, sometimes we don't just design like this, but in some cases this kind of design works. So I'm just gonna carry on. So the flange is gonna be like this. So instead of putting this, I'm gonna put a parameter nomenclature here, depth equals to 150. Yep. So there will still be the door, but let's just you might want to use it like that. Make depth 150. The door will carry another extension for the depth. So in some cases, to find those corners, we try to sometimes we don't want filling along the more or less like this corner lap weld, but we want something like a something close to, well, it's going to be a lap, but it's going to be inside, not external, and we want it consistent. So sometimes we use this corner seam. Corner seams allow you to reset the gaps for the seam along the edges. Select the edges that you want to treat, and if you look at it, it's either the plate flush with the top, or the top flush with the side. So for this case, I would like to have this. Then you can reduce the gap size so that you don't have to fill that corner too much when you are giving in the fillet weld. So apply for this one. Do the same thing for this. Also, this. You need to check properly. For this, you use this. You apply gap divided by 6. Apply. For this one too, we are doing the same concept. Yep, like this is fine. Yep. So this side sort of the same. So I apply, and for here you can click here. Just make sure that you understand where how they flow into each other. Apply. Fine. So you do save. Then you do save. We now create a flat pattern. You know, unfold everything, and you have your bend lines. So that's how it's gonna work. So what we try to confirm is this depth. Hope it won't be too much for bending, such that when you're bending this side, it won't clash with this side if you bend this first. So the press brake personnel asks you in achieving the stacks. Well, during your design, you want to ensure that you don't give them complicated concepts that will make things difficult. So those are the things we look at. Now, if I add another flange, that might give some other issues, but I'm going to go ahead and do that. Choose another flange. So I just want a 30 flange of 30. Come in here, select this. So in case you want to keep changing this one, you can name almost all your parameters in case you want to have a design that has a varying flanging and stuff like that. You understand? So in this case, I actually want a concept whereby the concept I'm looking for might not be like this, but I don't think I want to use this. So just want to flange this side inwards, and another base to those ones with another concept of flange. So I'm gonna make these yeah. So something so here is I want to back out the corners because I need something coming from top. I don't want it flushing into the ones on the side, so do offset from both ends to 35, 33, 32, because I'm gonna have another 30 up and 30 down, so let's do 31. We take gap of 1, 31 to 31. If you look here, it's an offset. Okay, to click on this icon, it has the pen edit, so that the offset 31. So you can actually also define parameters for the offset. So you have the add luxury, apply. Okay. Alright, so for this, one flange, another flange. This is gonna be 12, 15. Okay, so in some cases for this, well, you know why I said 12 earlier, and the minimum flange length for 12mm sheet is 12.5, 11. The press rate can constrain itself to do 8 sometimes, but 12.5 is always sufficient for them. So most of just shows a round figure of the thing when we're working with depth over length, depth of flange. 12, then and then that's that for this. So for these, I need to find a way to flanges, and let's see, flanges backwards too, and make it same. Apply. So, yep. So if you measure, by pressing him, it brings up the measure dialog. We have 13 right here. So I told you sometimes the constraint is going to be able to do a level sometimes. So let's just make this 12 a bit shorter than this. One you want to keep thinking about when you're creating all this kind of thing is the capability of the machine to be able to achieve this. Sometimes it's always difficult, so you want to keep that in mind at all costs. So for this flange down here, we need 30 boots and 30. So you see the tolerance I gave was so that they won't clash. So but make it 31. So another thing you want to be careful of is this kind of things here too. See, this edge is the clashes at this point, so you want to be careful to make sure that you have a good backup. So same, so for here you can do the thickness of the sheet plus 0.5. As sheet thickness is 2, so you type thickness, because it's already the default meter plus 1. You understand? Setting the side straight that part. In most cases I won't do it like this because of this way I'm doing it this way. My concept won't be like this at all. So let's see. Fine, so you see. So then for this flange, I need to flange these guys up and these guys up. Then I need to offset by that depth I had before, offset. So sometimes I could link them together, so you have to do it twice, you understand? Maintain star offset for the similar flange that is around that area. So 31. Okay, so you need to say, so let's show from the front this way. So So yeah, apparently I still want it to be a bit close, not too steady. Alright. Alright, good. So sometimes we like to clean up this flange. There are ways to do it, many ways to do it. You come to this bend, the remnant, that's this B. Multiply it by 0 sometimes. Okay. So I keep trying. Wait, resistance work sometimes. Okay. Sometimes so we do this. Okay. Make it off from the edge. Stuff like this. And it's gonna line up this way. How we do this way. Line up this way. Yep. Then this is gonna be same depth as what we have there. 13. Yeah. So apparently I click something and I don't want to click. Well, I need it to be at the same level with this so far. I'll do another flange. I will fix that part later. Do another flange. Same. Then has this one here. That's 12, right? Okay, good. In some cases, so I'm just trying to not very much. In some cases, see, could see if I could seam this together to form this kind of apply. It's gonna work. It's gonna let us know if it's not. They're gonna be clash with one foot. They're gonna let us know, so stuff like this. So let me just show you from this angle. You see it. Apply. So it seems the edges lock them at the same time to the corner while they're flushing properly. So that's gonna be the main body of our enclosure. So let's just say this is a wall mounted enclosure. Understand? And that's the first part. So the next part is our to build our door. Then another thing I notice is this one here. So I've noticed the gap there is wide. There are ways to fix those gaps too. You could see if this works too. If it doesn't, then let's apply this just to fix. If it won't work, it will let us know. So it's worked. So that's it. So there's a ways to fix your job. So you see it, everything flush properly. There's like a form of what's it called? There's a terminology for it. I remember. I'm gonna let you know. The corner treatment on that corner. That's what it did. It's gonna do a form of corner treatment, then give you a mitre. Yes, a good mitre. That when you unfold, everything works perfectly. So if this can be achieved with just one stuff like this, you could fill up this one. It's not a big deal. These gaps are not much, so see, find out how that comes together. You see different. So it's already telling you. It won't respond. So fine, so there are ways to do this, so it's not a big deal. What I want to do is the unfold. So this is how it looks like on the unfold. These are bend lines. Once that's done, you get this. So in the beginning, I didn't set the material type. Come here and set it for the just the part. Still, might stay. Apply. Okay. Then with that, stop here for today. You understand? So apply is gonna change the material appearance and everything. So I hope it doesn't crash at this point. Okay, so the material has been set up and then save. So so if you want to show your iPad, I could show you iPad from this software. So we have the material set up. Let me see, make it more realistic. Let's see, best can be. So this is it. So it could be wall mounted. We put a keyway at the back, stuff like that. Then have a door that sees it, that comes in. That will be fastened on this. Be a fastening hole or a cam lock that locks behind this to hold the door in place. Or a hinge. So that's that. We'll stop here for today. Tomorrow we'll go into iPads, then logic later.